Hello, my dear pre-algebra class. How are you guys? I'm going to do a short video today on lesson 9-4, direct variation. Two of the things that we will need to know how to do, let me enlarge this, is in this, what you will learn. The first thing is identify direct variation, and then you will use it to solve problems. The key to identifying direct variations is to look for these two features. Okay, something that changes, that we say it directly varies, are things like that you have actually been studying already. Questions that change with a constant rate of change. That was the last lesson. Okay, the two are almost exactly the same. The main difference between a direct variation situation or function is with one of these is that in a direct variation, it will always pass through the origin if there was a graph. Okay, if there's a graph that represents this situation, it will always pass through the origin. Whereas for a constant rate of change, you may or may not get that. You may have something that starts here, but it still has a straight line, showing that it has a slope that doesn't change. Okay, as long as it's a straight line and the slope is consistent throughout that line, it has a constant rate of change. Okay, but for it to be considered a direct variation problem, it has to start with 0, 0. Okay, and the graph will be represented by an equation like this: y equals mx or y equals kx. In this case, m and k really are the same thing. They're both the constant of, they're called the constant of, right, constant of variation, or the constant of proportionality. Okay, so it's a number. Okay, that's why we call it a constant. So the equations will look something like this: y equals, say, like 4x. Okay, where the only number that's showing in the equation is this constant. Remember, whenever we have equations that have x and y, when you write the equation, the x and y remain variables. Okay, we don't write numbers in these places. The numbers appear in the other places. Okay, but the x and the y, they have to change in different situations. Okay, so like, for example, here is an x and here is a y. That works in this relationship, but here is also another x, right? This is another x, and here's another y. Okay, and these various x's and y's, they all have to be able to fit this equation. Okay, that's why we don't write a number for the x and y, because it's a variable. Okay, so you notice here again, right? Here's one that increases by the rate of 2 over 1. You see, if you change one place on the x, it goes up 2 on the y. That's why this constant is 2. Okay, and it goes through the origin. So here it says a direct variation is a relationship in which the ratio of y to x is a constant. And the constant is represented by m. So we say, this is how we describe it in words. We say y varies directly with x. Y varies directly with x. And to figure out the m, okay, the constant, we take y and divide it by x. That's how we get the m, how we get that constant. Okay, so read this part in your book. Okay, it will tell you that it's also the slope. Okay, this constant is also the slope of the line. That's a very important thing. So if you ever get a graph, and if you want to find the constant of variation, you just have to figure out the slope. Okay, so in this case, the cost varies directly with weight. As the weight goes up, as the weight increases, the cost increases. So what is the constant of variation? Well, if you say If the weight is 2 pounds, then the cost is $7. If the weight is 4 pounds, then the cost is 14. So we can find out the constant by dividing 7 by 2, which is 3.5. And then the other one was $14 for 4 pounds, which is also 3.5. So we know actually the cost is $3.50 per pound. Okay, so that's how you do these types of questions. They're very, very simple, as you can see. Okay. Here's another example. Okay. I want you to kind of read through these yourself. I don't want to make a very long video. Okay. This is a good question also. The C, they ask you, is this a constant of variation? And the answer is actually no. Okay. If it were, you would have to multiply it. Okay. Let's see. Let me make sure I got that right. Okay. And here's how you use it to solve a question. Okay. It takes time to burn a CD depending on how much information there is. So the more information there is, the more time it takes. On this graph, you can see that if you have 2.5 megabytes of information, it will take you 10 seconds to burn it on the CD. If you had 25 megabytes of information, it would take you 100 seconds. So what is the constant of variation? Well, 10 divided by 2.5 is 4. 100 divided by 25 is also 4. So your constant is 4. That means it takes 4 seconds to burn 1 megabyte of information. And if they ask, well, how long will it take to fill a 700 megabyte CD, you just say y is equal to 4x. And if x is 700 megabytes, you multiply that by the 4. This will give you the answer, 2,800 seconds. Okay. Okay, so I hope that's enough to help you guys solve these problems. Here's another problem where you have to compare things, which is still kind of the same. You're just dealing with two different equations. Okay, so I'm not assigning anything from your book today. They're all going to be on worksheets. So please look in here. Okay, when you go into your McGraw-Hill, yours will look different. It doesn't look like this. Yours will look like, it will say homework, okay, somewhere here. So go into homework, click on that, watch the videos, do the worksheets, and this is due next week on Tuesday. So you have lots of time to finish this. And I also am going to upload this video here on your Google Classroom. Okay, so have a very good weekend. I will talk to you again on Tuesday.